So once you reach to this site, then this is easy. That's it. And here, 3 columns are there clearly, 1, 2, 3, and this is the fourth. So our target is to focus on the third one because it is telling that this is a server. So this is the one which we need to download. Okay. So I'll click on it and it will come to this page. So one important knowledge is you see the options here. Observe. You have an option called Red Hat CentOS. You have an option called SUSE Linux. You have option called Ubuntu Linux. And there is no option for Windows. So what does it mean? Confirm guys, what does it mean? Can we use the Windows server, Windows operating system as a server here? No. You understood? So option is super clear. So for a Linux, the server has to be, for a chef, the server has to be a Linux. So that is a clarity. Now here we need to make a choice. We know that we are using this one. So that's the reason I click on this. Now here you have 2 choices. Now you tell me guys which one you guys will download. CentOS 7 and CentOS 6. Which one you guys will download? If this is 1 and this is 2, what is your answers? So definitely you guys have to download 7 only because I'm using CentOS 7. No, it cannot be any. Arjun, it cannot be any because this is for 6. We are using 7. I'm using CentOS 7. So that means this is the one. So click on the download. It will ask you to fill some biodata. Kindly fill it. I'll fill Modi, N, Narendra. You can fill dummy guys. It does not matter. N Modi at gov.in government. What company? Government company. Yeah, Indian government. You can fill dummy. Job title, Prime Minister. So which country? India. Phone number, I don't know his phone number. So I'll put 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Accept, download. Thank you for, okay. Now it will start downloading on your computer, guys. You can see it's downloading on your computer. So what it is trying to do? So it is trying to download on your computer. So it is downloaded. So our target is to transfer that file from Windows onto your computer. So this is sitting here, guys. You can say this is the one, right? So I want to transfer this file to my operating system. So what I'll do, please observe closely how I am doing. Close all this old stuff. Now get connected to your server. 192.168.1.210 is our server. Please connect to our server. Root. Yeah, we got connected. The moment you got connected, this left-hand side stuff will help you guys, this part. Okay, this part. So here you have upload button and downloads button. See. So I want to upload. So just say, click on upload button and go to your downloads. Just upload it. That's it. This is an easy task only. Click on upload button from your computer, upload onto this machine. So it is uploading. It's taking time. The status is at left bottom. So uploading the server, you can see server copy. So it is done. ls-l, press enter. Okay. So this is the one which we transferred. Now what you need to do is we have to fire the command to install this. The command is, please write it, rpm -ivh. So whatever the file that you got, it is RPM file. So that's the reason we have to use RPM command, RPM -ivh, and type the file name and press enter. So it will start installing the package. So we are just waiting for this to get it done. So this we are going on, right? It's at 40%, 43%. So once that is done, we can shut down the server. Then we'll proceed with workstation. So it's almost at 93%, 96, it's done. Okay, so you got your prompt back. So the work is finished. Okay, so that means I can say here it's done. Software is installed. Next target is this fellow, workstation. So now go on to the internet, same, the place where you downloaded, guys. Please go back to the previous page and the same page where you got your, see, same page where you got your server. The same page you have now. You have to focus on this one now, workstation. This is the server copy and this is the workstation copy. In the same page, you have the client copy also. 3 different copies. So now this is our target. So we'll click on this workstation and we'll try to. Okay, now see a lot of options we have. We have Red Hat, we have Mac, we have Ubuntu Linux, we have Windows. So my target is to go on to this one. So what I'll do, I'll click this and you have options now. You have 2 options, 7 and 6. We clearly know that we are using 7. So we'll go ahead and download this copy. So click on the download. It will start downloading the software on our machine. And our target is to transfer this onto the workstation. So it is done. Now connect to the workstation. What is our workstation IP, guys? You remember? 220. So we kept 210 as server, 220 as workstation, and 230 as a client. So 220 is our workstation. So we got connected. Root, enter your password. Then next, click on the upload button and copy that file here. Okay. So we came here. Now check it. It gets transferred. Yeah, this is a file copy which we transferred. The same command rpm -ivh and put this. It will start installing the software. So it's almost at 72%. So it's going through. So it's now around 87%. It's almost getting done. 100%, it's done. So we need to wait until we get prompt back. Yeah, we got our prompt back. Okay. So, okay, so it's talking about some dependencies. So not found, not found, not found. What is this? So to run the experimental chef workstation app, okay. So we do not require this. Now, the next, we'll update our sheet. So this, what we install, guys, we install something with chef workstation copy. And this is done. And then third last one is chef client. So we'll connect to the chef client. Before we connect, let's download. We'll go to the same place. Yeah. Here, this is the one which we need to download. So I'm talking about this one. Chef infra client, guys. So click on this. And you have a lot of choices, very lengthy choices. AIX, lot of choices are there. So my target is Red Hat CentOS. Click on this. And here you have 8, 7, lot of options are there. And definitely under 7, I guess there are 1. Let me write it. This is 1, this is 2, this is 3, this is 4, and this is 5. And you guys have to tell me which one I should install on my Oracle VM box. Is it 1, 2, 3, 4, or a 5? And you have to be exclusively be careful at this while installing the client, guys. Some students, they pick up the wrong version from here and they will knock their heads. Chef will not configure properly. You'll keep on getting errors. The problem is you guys have downloaded the wrong one. That is the reason. So you have to tell me, is it first, second, third, fourth, or a fifth? So the answer is this, the first one. Okay, please write it in your notes. If you unnecessarily copy the wrong version onto your machine and trying to experiment, and things will not work. Okay. So click on the first one and download it. So it is trying to download. So download is finished. Our target is to connect to the client. 192.168 1.230 is our client. Accept and say root and put the password. We got connected. Okay. Now, once you got connected, our duty is to transfer the file. So click on upload button, upload the chef file and put it here. So upload is done. Type ls-l. This is the file which he transferred. Same logic. rpm-ivh, type the chef and press enter. It will install. Okay, this is done. So let me update my table. So this is also done. So this is done with a static IP. This is also done with what you can say the software, that is chef client. So are we clear on the steps so far, guys? Confirm. So we created the 3 machines. Each machine is configured with the static IP. And on each machine, we installed the target software which is required. And we went to the official site only. We did not go to any third party. We went into the official site, we downloaded the software, and we installed it on the client machine. And the next part is Next part is what I think it's a configuration stuff. So let me see. So these are all we done it. Yep. Okay. The next part is Chef architecture. So I want you guys to take down this official diagram. So official diagram looks so silly. So please take down. So let's focus on Chef architecture. Please take down this diagram, guys. And then I'll try to write our diagram. Please draw this diagram of Chef architecture. Diagram looks easy only. Okay. I hope you guys have taken this. Now let's go on with our diagram. MS Paint. Let me draw it. So let's assume that where is this rectangle symbol? Okay, here it is. Triangle symbol, sorry. So let's assume this is our server. Okay. And this is our workstation. And this is our client. Or let's got it. So let's first put it. So I'll put for client a separate box. So this is our client. Okay. So in the client box only one is there. So let me write the namings. So this is our server. And this is our workstation. And this is our client. And this machine has to be a Linux. We know it. And common points are, I'm writing the common points right hand side. Entire architecture should be on static IP. And all pieces should be 64-bit. No use case of 32 at all. All should be 64. And server has to be a Linux. But whether it is a workstation or a client, you have a choice. You can go with Windows. You can also go with Mac. That's okay. But server has to be a Linux. Now, this is a 3-tier architecture. This is a 3-tier architecture. So this fellow looks a little different. All other configuration management tools are 2-tier architectures. They have a dedicated server and they have a dedicated clients. That's it. There is no mediator in between. Okay. But when coming to the Chef, they brought up the third person here called workstation. Now, why do you think they brought up the workstation? So they brought up the workstation. The reason is, let me write the reasons here. The reason number one is to reduce the load on server. This is a simple agenda. Simple reason is to reduce the load on the server. In a 2-tier architectures, what happens is generally on the server we write the code. You remember, guys, in 2-tier architectures on the server we write the code and then we test the code and then we fire the code. This is what flow happens. We write it, we test it, and we fire the code. So after this activity, the server has another responsibility is to manage the infrastructure also. You understood? It has to manage its client, you can say. It has to manage its clients. So this is definitely creating the load on the server. So this was a common problem way back in 2000, I would say 2006 or 7 era. So understanding this problem, Chef has come up with a solution saying, so no longer 2-tier, they brought up something called 3-tier now. 3-tier architecture system. So what is the 3-tier? They brought up separate person called workstation here. So you have a server and you have a client So in between, we got a guy called workstation. So what this guy is doing? So this is a place where we log in. See, interesting. We write the code and we test the code. If everything is fine, then only we upload the code onto the server. That's it. Okay. Then only we upload the code onto the server. So once you upload the code onto the server, clients will come and pick up the code and implement the whatever it is written in that script. So if this is happening in that direction, can I say that the load on the server is reduced? Do you agree, guys? Because we directly don't log in into the server directly and write the code there, test the code there. Everything is happens, final output goes onto the server. And server just gives it to the client and manages the infrastructure. So this seems to be more effective. So that is the reason it is 3-tier. Am I clear on this point? Confirm. Divya understood, Kirti, Stavya. So the intention was to reduce the load, guys. Unlike in 2-tier architectures, so it has to manage the both the things. So something like it has to put a lot of effort. But here, effort is reduced. Now, let me write few more points here. That means we are going to I'll write it here. So this is a place we write the code and test the code. Okay. And finally, we upload. So we upload onto the server. So where you upload? We upload to the server, guys. Keep that in mind. So that means the direction of the line will be like this. Yeah, like this. Oh no, it's far better. I'll put one line. So from here, it is traveling to here. Got it? So that is a flow. So from workstation, you will upload onto the server. So once that means, let's say this is a code which is sitting on the server. And what happens is now clients will come and pick up the code from the server. Now, what is this technology called as, guys? Is this a push mechanism or a pull mechanism? Is this push or a pull? Confirm quickly. It's a pull, not a push. Okay. So in the push mechanism, server will send the code to the clients. That is a push. In a pull mechanism, clients have to approach the server to pick up the code. Direction is reverse. So that's the reason this is pull. So the common point is, what is the common point now? So this is operates on pull mechanism. Clear? So this is another technical point. Now, another technical point here. On a workstation side, I told you, right, we write the code. Correct? Now, where we write the code? So we write the code in a place or in a file, we call that as cookbook. Cookbook. Like in Ansible, we said playbook. Here we call cookbook. And in the cookbook, okay, so to write a cookbook, we use Ruby DSL language. So DSL full form is domain specific language, Ruby DSL. So we are going to use the Ruby DSL to make sure that we write the cookbook. So to write a cookbook, we have to use Ruby DSL, guys. And interestingly, Ruby DSL is super easy than YAML. So nothing to worry about Ruby at all. Okay. Then now between the server and between the workstation, there is one important configuration file called as knife.rb. Knife.rb, guys. So this knife.rb file is created on the workstation. So that means, so this guy have to move it here. So knife.rb file will be created on the workstation, and that file will help us to communicate to the server. If the knife file is not working, then from the workstation, you will not be able to talk to the server. Clear? Nothing can happen. So on the workstation, we have to create a knife file which helps us to communicate with the server. So that is a lot. Likewise, a server will communicate to the client based on a file called as client.rb. Let me write it here. File called client.rb. And this file resides on every client. Every client case. So let's say if you have, what is this? One more client here, one more client here. You can have a number of clients guys. There is no limit. So in that group, you can have a number of clients. So there is no limit. On each client, you'll have this file, and this file will help you to talk to the server. So workstation talks to the server based on knife. Client talks to the server based on client.rb. Now, there is one more important point to be noted here. So there is a concept called as run list. So what is this run list build is going to do? So run list helps you to tell the server to assign what cookbook for what client. Okay, I repeat once again. Run list of chef helps or declare to distribute a cookbook to a client. Or if I talk in our normal style, in a normal life case. So I hope you know this example very commonly happens in our life also. So let's say elders are there. So elders, if they got the property with them, so what they do, they write a document, registered document. I'm talking about that registered document. Okay. Registered document, which will tell, so let's say there are 2 daughters and 2 sons, and they got some properties. So in the document, they'll declare, okay, A property should go to the son, B property should go to the daughter, and C property should go to the granddaughter or grandson, whatever it is, and D property should go to the granddaughter. You understood, guys, what is that document is helping you? So that document is helping us to clearly distribute the property among the legal heirs. Likewise, here, once the cookbooks are uploaded onto the server, so on the server, multiple cookbooks can be uploaded. So once the cookbook has been uploaded, so server definitely will contain, imagine there are 10 cookbooks out there. So it does not mean that if a client comes, it will not hand over all 10 cookbooks to it. So it looks into the run list. It checks in the run list. So let's say, example case, there are X, Y, Z cookbooks. Okay. And this is 1. And this is, let's say, this is 2. And this mission is 3. And let's say this mission is 4. Now, in the run list, you have written in such a way that X should be given to the 2. That's it. So what happens when second computer or second client reaches to the server? It will check in the run list and it picks up the X cookbook and handovers to the client. And client will pick up that cookbook. It will implement on its machine and comes back to the server and reports the status, whether it has been successful or failed. You clear, guys, what I'm talking? So that is the concept of run list. So I'm trying to explain the terminologies here. So we came to know the server, we came to know the knife, we came to know the cookbook, we came to know the run list, we came to know pull. Now, one more terminology I'm introducing called organization. Called organization, guys. So, what is this organization stuff? So, in a organization, technically, according to the chef, they call it as organization. But if you talk informal style, according to us, we call that as a project. So, in that project, you will have collections of computers. So, let's say this is an IBM. Okay, imagine this is an IBM. So, likewise, we can create one more. Okay, so let's say this is the one more, and I will call this as TCS. In TCS, there are three machines. In IBM, there are four. So first one is an organization. Second one is also an organization. That means two organizations are created. Make sense, guys? So organization is nothing but project. So in an organizations, we can have n number of collections of client computers. And interestingly, the matter is very complicated here. That complication is a workstation is configured in such a way that it can only talk to a organization only. So that means, so what I'm trying to tell you is a workstation will reach out to the server to do the deployments upon this workstation, this organization. In this organization, there are four. So that means this workstation is capable of hitting on IBM only. That is what I'm trying to tell you. So if you create one more organization, then definitely you need to create one more workstation. So the simple formula is the number of workstations will be proportional to the number of organizations. Am I clear on this point now? So no workstation is allowed to talk to multiple organizations. So each workstation is configured to operate with one particular project or organization. So in that organization, you will have the collections of computers. Are we clear on this point? So let's say if we have three projects, how many workstations are required? If you have three projects, guys, in a project or in an organization, you can have a number of computers or servers. So three projects means, or three organizations means, three workstations are required. And how many servers are required? How many servers are required? Only one. So simple formula in Chef infrastructure, server will be one. Okay, n number of projects can be there. Likewise, n number of workstations can be there. And the relation is workstation is always proportional to the number of organizations. So that is how this Chef infrastructure works. Are we clear on this now? Understanding of architecture? Confirm, Sravanti, Vijay, Sheikh, Amit, Sanjay, Samir. Okay, nice. So that is what the diagram have given here. Okay, a lot of it looks little complicated, but this is a diagram. Okay, one more point I forgot to tell you. The last one is Chef Repo. This one I forgot. Okay, so let's see. Come back there. So I told you, right, we'll write the cookbooks, correct? So all these cookbooks, let me write the points now. So all these cookbooks are written using something called resources. Like in Ansible, we used playbooks. Playbooks are written using the modules, correct? Modules are of two types there: built-in modules, custom modules. So likewise here also, guys, cookbooks are written using resources. In the resources, you have two types: built-in resources and custom. So I hope the meaning is clear. Built-in means already existing resources will be there. We just open up the documentation and we write, copy its syntax, and we write the code. In the custom, that is purely programming. So developers will go ahead and develop the custom resources if required. So custom resources are written using Ruby language. Now, what is this Chef repo? The last terminology. So there is a concept called Chef repo. So Chef repo, which sits only on the workstation, guys. Very important point. Chef repo sits only on the workstation, and the copy of this will sit in the version control system. So technically, we create the Chef repo in the version control system. We clone that onto the workstation, and all these cookbooks and this knife file, everything will reside inside the Chef repo. Clear? So Chef repo is nothing but the entire box of your, or you can say it's an entire box of your cookbooks and your test cases and your knife file. That's a Chef repo. So where does the Chef repo sits? The Chef repo resides on workstation, on each workstation, guys. Remember, all right? Each workstation, and a copy of this will sit in version control systems. So that's the use of Chef repo. Yeah. Now I want you guys to take down this diagram, guys. Since you understood, or you want to take this or take that, it's up to you. So please write this in your notes in your understandable language. So is it done, guys? Have you guys written? Okay. So that's nice. So we'll stop it here for the day. And tomorrow we have configurations to do. So configurations will almost take 2 hours of time. So that we'll do tomorrow. So let me copy paste this into your notes. Give me a minute, guys. Okay, so I have updated the notes, guys. So please check it. So that's all for the day, and we'll catch up tomorrow. Chalo. See you. Bye bye.